thank you. I want to thank you for volunteering to help me with my research project. I hope your students will thank you for bringing math magic blocks into the class. The whole point of my project is to answer a question which people that might be interested in putting math magic blocks into their curriculum would ask, which is, does math magic blocks make a difference? Does it improve test scores is the most obvious question. And though I know that math magic blocks is important in far more important ways than improving test scores, for a lot of people, improving test scores is a very essential part of what they're trying to do. So, I'll tell you a little bit about this test. It's called the Wilcoxon Rank Sum Test. And what it does is it looks at two samples of data, in this case the control group test score and the test group test score. Control group is your kids that are having just a regular lesson for teaching whatever the subject is, multiplication, let's say. The test group is the group that's going to be having the lesson, but part of the time, and an equal amount of total time is spent with each group, will be spent playing with math magic blocks. Now, it turns out there's a lot of tests. When I took statistics, this is a book that has lots and lots of tests, and every page, every chapter is filled with a different test for a specific situation. So the test which I'm using, which I will send you another link for, it's actually on YouTube, and it's a 12-minute video from a guy who's actually doing, I think, a really good job. I'm a geek. I love science and math. It looks like this, but I'll send you the link so you can see it yourself if you're interested. But I'll just tell you briefly what's involved. If you have two samples, then you're going to get maybe kind of a bell-shaped curve for each of them. Now, if the control and the test groups look like this, then clearly there's a difference. Now, it may be that the math magic blocks actually lowers test scores compared to the standard method. I'm hoping that's not true, but it's more likely that there's going to be some overlap between the two bell-shaped curves. And if the overlap is sufficiently large, considering the little bumps that come because the classes are not filled with the exact same students and whatnot, they'll never be exactly the same. But if they get a little too similar, then they say reject the null hypothesis. And the null hypothesis says there's no difference between the control and the test groups. So the Wilcoxon Rank Sum Test does that. And what it does is it takes every score from every kid and it just ranks them all. It throws them all into the same big bucket. And then it looks at which ones of all of those kids, when they're all laid out in a linear sequence, which ones are from the control group and which ones are from the test group. And if more of one group is higher up than the other group, then that's a indication, and they do some fancy stat that I don't understand, but it's pretty cool, then that's the indication that in fact there is a statistically significant difference. And they can calculate the difference. They can say there's a 90% or a 95% or a 99% probability that there really is a difference. And that would be gold if I could find that out. If I find that's not true, well, then I will have to try to get math magic blocks out in classrooms because they're fun and they make kids enjoy math. But we'll see what happens in either case. So I'll be sending you a link to the actual test if you are a geek like me or just want to find out a little bit more about what the test is. He does a pretty good job of explaining it. He does a very good job, but at one point he has to do some hand-waving and talking about a couple things that I didn't understand. But you'll see the actual process if you care. And if not, then good luck with your math magic blocks. We'll be talking to see what sort of specific test you're going to set up. And I wish you best of luck, and I hope your kids have a good time. That's all for now.